Thank you very much. So my talk will be a little bit less enthusiastic because this talk is made from frustration, not from enthusiasm. And you will soon maybe understand why. I will be talking about importing and exporting code, which is currently a big problem in JavaScript, not only to understand, but also to get right. And with some introduction, at least, I'm from FlowUp. I'm head of engineering there, and with these great people, Julian, Chris, and also others from Push-Based, we are working together. We have a beautiful collaboration. I was just talking about that it is almost 4 years now, so yeah, it's a great 4 years. So let me start. It will be a little bit of history. So wake up. There will be quiz. So don't afraid to shout things. It may be hard, but I really expect some answers. So does anyone recognize anything on this picture? Okay, I'm looking for good Bitcoin. Yeah, I'm looking for a year. What year is this? Well, Marek cannot guess because Marek knows. He was looking in a train. So Bitcoin, yeah, Bitcoin was a thing, not only a thing, it was first published. Michael Jackson died. Obama was elected. No?
2012.
12. No. 1970. Okay, it's 9. It's 9. What else happened at 9? No one knows. It's a long time ago, but it was beginning of CommonJS. So it was developed. It was the worst thing since swine flu, and it got popular with Node.js, and that was one of the biggest problems back then because and it was one of the biggest problems back then because Node.js is like at that point it was a server language, and it created a special variable called export, where you could assign things, and it also created even more special thing that was a require function, which to this day haunts many people. How does this import system work? So it is requiring files, of course, because most of the JavaScript world is at this point just a bunch of files. And then files are executed. They are exported synchronously, made available for every importer to get it. And it was, because of Node.js, designed as a server-side require language. Import system. Fun fact: it was called server.js when it was first developed. So that also speaks on what was the purpose there. It expects that everything is available locally. Again, on server, everything is in file system, so it worked, but it somehow got into the browser. And when it got into a browser, this require started to be a big problem because it's a blocking operation. So why it works is because it literally waits. It waits until the file is downloaded via network. So then there's this here. I will not ask you about each of the picture, but there are much sadder things than in 2009. 2009 was a good year compared to this one because Syrian crisis started. Paris was, I don't know, horrible things were happening there. Some pilot decided to crash into Alps, and it was confirmed that Pluto is indeed not a planet, which was a horrible thing also. So yeah, it was 2015. And in 2015, what happened? Nothing. ECMAScript modules appeared, and they got introduced. This doesn't mean that they were used. They got introduced. People were looking at it like, this might be a cool thing. So there was an import and export on top level as a keywords. It suddenly started looking great, like a proper language. There was a designed to work in a browsers. It was by design asynchronous, and as I was saying, it took 5 years until this was actually accepted and fully shipped in Node 12 in 2020, which is, what, a few months ago. No. 2020 was not so bad year at all. How does ESM work? Internally, it is a top-level await, which, for these that know what it is basically waiting as a promise is returned from any import. It comes with dynamic import, which is very useful, and we will later on, stumble upon why. But in general, even in Angular, you probably remember that the rules got refactored to dynamic imports, which are, from Webpack, not from ESM, just to be clear, but they work similarly. And everything could be suddenly imported at runtime conditionally. Yeah, times were great. Amazing thing about the ESM modules, they are only executed once. So even with the import, that's a thing where people are afraid to import multiple times dynamically. It will only happen once. The module will never get executed more than once. There is, however, a problem with ESM and CJS. Many have tried to solve this problem. I don't think it's really solvable, or maybe it is, but shut up. Yeah, it's the biggest divide of the community, because if you look at NPM packages and libraries that are currently shipped, there is like 70% in CommonJS, something in between which has both, and then, I don't know, 7 or 10% that is doing ESM. And the cool thing is that ESM is completely fine to import CommonJS. Like, yeah, you just do it, and there is some hassle in TypeScript. You have to configure things, but it will work. Problem is, tree shaking won't work. But yeah, we can move past that. No, you can use your library on the cost of not having it tree shake. CJS cannot import ESM unless it's special constructed with dynamic import and promise, and yeah, a bunch of things need to happen there. It's quite a lot of engineering, to be honest. I was trying to put it on a slide, and I was like, no, because everyone will leave. So yeah, let's talk about actual problem. There is dual package hazard. What does it mean? Well, even if you do all of this engineering to wrap the CJS around, there is still potential hazard that one of your developers will import ESM module of that same library. What will happen is that now you have a totally same libraries running twice in your application. And if you imagine that this library would be authentication or something, serious, it's not good if you have the same library doing same thing in a different way in a different context. So this is a big issue, not really easy to get around. And compilers play a huge role in what we are actually using. Can I ask you, does anyone know what we are using in Angular? No, Michael doesn't. That's already a bad sign that, one of the GDEs in this room doesn't. No, I'm joking. So we are using ESM because of TypeScript and because of the Webpack compilation. From Webpack 5, I think everything is on ESM. That's why you see that yellow line that CSM may cause optimalization bailouts, this horrible line which you solve by ignoring it. Yeah, so this is happening, and this is our real life now. If you don't know what you are actually outputting, because you could be outputting CJS, and we will later discuss why, you can actually check the bundles that are in your dist, and once you see required, you know that you are using CJS, and once you see imports, then all is fine. So this is the reason why you might still need a CJS. It's slower. ESM is slower for larger applications. This is a real thing, because entire module graph needs to be loaded. And that means that each statement, like this curly thingy that you use on top of your thing as an import, or if you do an await to a dynamic one, For each of these statements, entire module graph, entire dependency tree needs to be constructed. Everything needs to be understood so that code is in. And this takes time. There is overhead. Also, lazy loaded packages return a promise, which is another overhead. Not a big overhead, but overhead nevertheless. Require didn't have this problem. Require would just wait for the network. That's it. So it is slower by design, and this is even more, like, why is it slower by design? So two passes need to happen before all imports can be binded. Why two passes? Well, the entire module graph is parsed and analyzed, and only then codes get evaluated. So it knows, nothing shady is going on, everything works. We have stuff that we need at runtime, and we can continue. And this actually has a side effect, which is a feature, and that feature is called life bindings. And I was asking the most knowledgeable guy I know from JavaScript, Maciej, this today, what is life bindings, and and he didn't know, and it made me a little bit sad and a little bit happy at the same time, because now I can explain Maciej what is life bindings. So what are life bindings? We have two things, ESM and CJS, side by side. Do I need to explain? Okay. First one is simple counter function that will add one to let count, and in the main.js, in both ones, you are basically logging, incrementing, logging. Can you tell me what will be output of ESM and what will be output of CJS? Someone? Well, CJS, what will be logged? There are two console logs of count. Michael.
You said ESM loads asynchronously.
Yes.
So if it loads asynchronously, just to be sure, right? Will it block the first import line or will it proceed?
You know what? It doesn't really matter.
No, it does.
Why?
Because if you block, you will not process any other code line. If you will,
yeah, for sure. It will be. Continue. No, it won't continue. It will.
It's most probably the same.
You would think, yeah.
No, I don't think. No.
So the thing is, Julian. Yeah.
If it is not asynchronous, anything parallel, it has to be the same.
Well, I was also thinking that, and I was not believing this is a real thing. But then I created stack blitz, and at the middle of the night yesterday, I verified that indeed ESM will output 1, 2, and CJS will output 1, 1. It is very interesting. This means that the execution context is could be different for these modules. Like not execution context. It's not the right word, but the whole life cycle of that module is pretty much influenced there, because for CJS thing is just a text. It will just pull in the text, understand the code because it's parsed, and all the things that needs to be done. And then it will not allow you to actually modify something that is already exported from that module. So if you are modifying something that lives in CJS, you will be not able to do that. With ESM, you are. I'm not saying this is useful feature, but it's a feature. They documented it. Cool thing. Life bindings. Remember. So Ban solved this. This is a little bit of spoiler for. Ban is great, but thing is that they fixed the problem, but they fixed it in a very interesting way, and that is that they support both imports at the same time. They don't really distinguish between them. They just, they say, let's look at the spec. Let's implement how they should behave. They behave basically same as ESM. and therefore they are not spec compliant because they are actually not following one of the specs. But the thing is that it just works. Why it works? Because they implemented the whole import system in Rust. They are not caring about JavaScript at all. So yeah, great, fun. Really, like, give it a half a year, we'll all be using it. That brings me to a point. Should I still use bundler in a world where ESM is a thing and imports can be already loaded and all is great, except CGS Libs? So should I still use Angular with Webpack, with Vite in future, with I don't know, React in whatever the React users do nowadays? Yeah. So good. Yeah, you should. And it's simple why? Because it is statically analyzable, the whole syntax. You can in a build time actually have a look what's happening in your whole application and create some kind of a more intelligent tree with your dependencies. And bundles optimize the code. They do use elimination techniques and they remove the unused exports, which is pretty useful, because if they wouldn't, then we would have, again, great problems, because we would require the whole dependency tree. And as I said, the whole module tree system graph needs to be understood, which is slow, which is slowing things down, which makes your tooling horribly slow. So yeah, it's great if you can have a bundler, and then if you are actually using Angular with Webpack and shipping your production application that way, you are not caring about ESM is slower than CGS, because it will be negligible, because your main JS is so small that it doesn't have an impact on that. And you are probably depending on 1, 2, 3 shared chunks. So it's all cool, no problem. Chrome team actually recommends using bundlers for production apps. They are saying, forget about local builds, forget about small things with just 3 things together. You don't need it. But as soon as you are shipping to production an actual SPA, please use bundler. Yeah, and this is from official analysis of Chrome pipeline execution. Their numbers show that unbundled project, it's the same project, but bundled, unbundled, but modules are preloaded, bundles are optimized, and it is completely in the best state it could be. And this is how long it took to browser doing browser things, preparing everything, so it can start happening to final render. And with this all now closed, ESM versus CJS, because they have their place in our lives, and we'll see. Maybe we won't even care when we start using BUN even in Angular, which might be true soon. We don't know when we get rid of Zone.js, probably. Yeah, so exciting times ahead of us. But we still have this one ancient technology, or not even technology, because whoever would call this technology is insane. So we have barrel files. Does everyone know what a barrel file is? So some do, and usually the ones that do are not having a nice expression on their face. So yeah, exactly. This is a barrel file on what is it? Left for you. So,
it's also left for you.
Yeah, I needed to check. Good.
Is this
It's the same.
Yeah, Julian, come on. I'm now confused. Okay, so on the left, you can see a barrel file with one collapsed import where we are selecting things. It actually exports, and on the other side, right one, you actually see the right implementation of how this should be done without barrel file. Now, really, we get into it. So you have basically these two options: either you have a long import list, or you have a barrel file and basically have a same amount of imports, because you are still you still need to do imports for all of this, It's not that it would magically, do it at once or something. It still need to happen. It's still processing. So not much overhead over this, but this is the overhead, the barrel file itself, because as soon as the system will see not stacked import but var file, it needs to create the whole dependency graph for its insights. So this is actually the problem. There is a huge slowdown in tooling, and the bigger the project is, the bigger the slowdown can be observed. This influences build, this influences lint, this influences tests, and so on. It has a bundle size impact, believe me or not, but as soon as you get rid of the barrel files, your modules, your chunks will magically start being, way healthier, way smaller, and everything will probably resolve itself. Maybe I'm making this a bigger deal than it really is, but try it yourself. In one of my talks, I have actually a pretty amazing example where we split it utils file into separate utils, separate, like really one by one almost, or things that are used together live together in one file, and the 60-something imports that were in the file suddenly stopped being part of the main JS bundle. So it can really solve some of the problems that you are facing. And also there is a boilerplate. You have to write these re-exports, and you have to take care of them. And if you move something, they are not moved automatically. And it's all horrible. This is something that is from era of ancient JavaScript, I don't know, 12 years ago. Horrible. So what is the actual impact of using the profiles? This is the common misconception. Like that's why I put X there, because it's not true. Modules are not only loaded in when they are needed. If you put things into your barrel file, then all of these things are evaluated. They need to be looked into, because what if there is a side effect in one of these imports, which is totally a thing. Like some libraries, video players usually put something into a global window, and this is a real thing. So it needs to be checked. It is not just magically skipped, as most developers think that it will never look into this thing that I'm re-exporting. No, it will. It will not only look into it, it will also look into what that barrel file is doing, and that one, and that one, and that one. And this is a vicious cycle of, I don't know, 15 checks. Yeah, this is what I was explaining. Everything loads, everything is parsed, everything that is needed is also executed, if it's called. So another exercise, execution order. We have 3 files: feature A, feature B, feature C. One is assigning 1, 2, 3 into global disk foo. Other one is logging that global disk foo, and the third one is assigning 42 into a constant X. And then we have a barrel file for all of these ABC, and then we have a main.js which imports just X from that feature of that barrel file and logs that X. Can you tell me what will be the output? You just need X, and by that logic you could say, it will be X. No, it will log 42. Not really, it will log 1, 2, 3, 42. Yeah, so here you have it. Everything is in that barrel file, and that means that everything might be needed. And this is a perfect example of two side effects. All of these side effects needs to be executed. So it has effects on performance, and it is not really important, pun intended, how many lines does your component have. So if you have a bunch of lines there on top, it's not really important how many there are. Like you can, of course, make it nicer, split things, but you don't really need to care. What you need to care, what is important, is how many files along the way are taken into context when importing. So that means that as soon as your project re-exports everything 3 times, and you have an NX structure of Libs that also does that, and then you execute some tests on it, for example, because why not re-exporting text in a biofile so imports are shorter. This has a huge impact. It can add up, and there is an official wait, official is a strong word. There is a benchmark, and there is a benchmark, and in this benchmark you can see what is actually happening. So there is a test runner, and each of these test runners has its own child process. And if you are creating module graph that will take in a project that takes 6 seconds, and you have around 100 tests, then you are wasting around 10 minutes in total, repeatedly trying to construct the module graph. And I'm saying you are wasting 10 minutes. That doesn't mean that the test's execution will take 10 minutes. That means it is 10 minutes on top of that, just because of imports. And there is great chart of how, I don't want to say logarithmic, but it looks like it. The execution overhead is happening. So you can see that on 500 modules on pretty small project, you don't really care. It's overhead of seconds. No one cares. 1,000, double that. No one cares. But as soon as you're at 10,000, suddenly it's more than a minute and something. And then 50,000, you have 20 minutes overhead on running your tests in a CI or locally. And imagine this is, for example, lint, and you want to lint on, I don't know, push maybe. So yeah, prepare for 20 minutes overhead on top of linting. And you know what? The more test runners you are adding, the bigger the overhead is becoming, because every of the test runner needs to execute the module graph. Not only the first one, every of them, each of them. Thank you. So, so effect on bundle size. We are not done yet. This is a quote from Angular team. Verifiles are known to cause optimization bailouts. I couldn't really find yesterday the issue where this was mentioned, but it was mentioned. And in the end of the presentation, there are links to these issues. You can read it out. So you would think that if your lib is completely tree shakeable, you are fine. And this is something that Julian told me. If your lib is completely tree shakeable, you are fine. And I agree. If Rx Angular is completely tree shakeable, you are fine. If your whatever lib you are doing, with simple tooling like RxJS, for example, is perfectly tree shakeable, then you are fine. But you know what? I have a surprise. Your app probably isn't. That's really like
your Angular app probably.
Yeah, I've seen so many. So review and optimize your imports. You are probably gonna do much better job than the bundler will. And you are asking why then we use Webpack. Well, we use Webpack because of all these things you couldn't probably figure out on the first try. Those who know the graph theory from math, you could probably understand that, if you do the graph optimization long enough, you will get into the best result you could ever get. No, of course you will. But Webpack is doing it like 7 times, and then it stops. And then, yeah, this is good enough. And not only it is doing it just few times, so it's fast, it will also, once you do enough of some imports, it will just stop, and it will, when it see multiple of these barrel files re-exporting things, it will be like, they are really including it in, quite sometimes, like it's a 3rd file I find with this import. I shouldn't really optimize this. Let's put it in a chunk together. This is really what, with a grain of salt, this is what is happening inside of that file system based import. Yeah, so everything is optimized with assumptions made by a compiler, not an architect or someone who actually understands what they are doing. And again, one more time, CJS barrels will never get reshaken unless you have some kind of special plugin, something. But yeah, in Angular Webpack, in what you are doing for production, they will stay. And as soon as you put such a library in, and you have the library probably in a shared chunk or in main.js. So conclusion with Bear files. Finally, having some is fine. You know, if you need 1, 2 somewhere, if your library is having a few to re-export some of the commonly used things together, I don't know, component and some type definition for that. Yeah, that's a good idea. Why not? Let's do it. If they serve a purpose, like API restriction, maybe, you know, that's something that people that use NX would say, oh, they have to be there because then we can define what is a public and private API. Well, there are mechanisms to do that without the profile. For example, you can enforce model boundaries and define that folder like private or internal shouldn't be imported outside of the library. Much better approach than actually keeping everything in barrel file. And if you use this excessively, prepare for a serious slowdown. We worked like in a project, it is now a second one, where we seriously suffer in a build time, how long it is, in how long tests execute. Developer experience is horrible. So don't get to that state where you actually need to, you know, create a pull request, removing every bar file in a project just to see if it works. And I already said that test runners, linters built, they are affected. So especially when you see these issues, maybe consider doing something about it. And we have some final conclusions here. Bundle your browser. Bundle your browser apps with things like Webpack, Vite, all the cool new things on a market. Start every new project on ESN. Don't start on CGS. No, you know, even if you are like, oh no, I'm really like, no, I like ancient things. Don't do it. And ditch the barrel files mostly. You know, you can keep 1 or 2 just to remind yourself how horrible ideas there are, but ditch it completely, ideally. And there is a bonus. Just because I was talking about imports, you can sort the imports, so you have less conflicts in your Git. You know, there is this plugin from Trivago. They don't only do hotels, they also do imports. So yeah, do it. Thank you, and this is the presentation. How was the time?
Good. 32 minutes, 34 seconds.
Really?
Wow.
Like your record.
Personal life.
It
has to be personal record.
Question.
doesn't happen on stand-up.
What a big and cheers.
Yes. Any questions, or was it comprehensive enough?
What's your favorite one?
Look,
I know your color is most probably white.
well,
No,
No,
I
it's
don't care about your
it's
color.
sad beer.
It's a serious question. You spoke about tree shaking,
yes.
and you said most probably all our packages and bits are not tree shaking.
No.
It's most probable. So maybe it is. I want to ask. You mentioned RX Angular is fully tree shaking. Is it true?
Well, it's not fully tree shakeable. That I know.
heard it is fully tree shaking.
I heard it's
Is it better than the most of them?
yes, and it's good enough tree shakeable. It's good enough tree shakeable. The API of RX Angular is pretty good. They like
Tell me more.
they
They do.
the experts in the team, you know, they know what they are doing.
I heard only good stuff about it.
Welcome. Please show the slide again with the CJS comparison, like with the console log in the very beginning.
Yes, please, that's it, Calvin.
Because
This?
I have no, not the
Show us
console.
the code.
I have
execute the code, please.
I had
Yes.
some
demo.
I had some epiphany when I thought about it again. Yeah, that one.
Here.
Yeah. Because it's so it makes sense. It makes sense. Because like exports.conf, here, exports account, you like duplicate, basically clone the value here. So you only mutate this here, but of course not that. Here it makes sense that you mutate the let you export here, exports.count. Exports is a new object which has a new property called counts, which is another like primitive number. So this plus plus count is not even touching this at all. Like it doesn't matter at which point in time this statement happens.
Exactly.
It will always be one.
There was even a little bit more comprehensive explanation on like on this, and I didn't copy it, but at the end of the presentation there is a link to Stack Overflow, and one of the people there, person there is explaining that the main difference is actually that ESM modules actually have the same memory allocation, like on a side of files. Sorry, not file system. The operating system. It is actually you are touching that count allocated in a memory when you are incrementing. Where here you are, as you correctly said, re-exporting the count in a special exports thing, and also like that file, the CGS file, is handled as a loaded text. Yeah, sorry. Oh.
On the left side.
Someone suggested it. It didn't work. Oh no, it did. Sorry, that would work. That would work, but that is actually it works because it is output of that operation, and then I would need another increment for you to see that it will output 1, 2, 2, and 1, 2, 3. So yeah, good point. Yeah.
I have a different question.
Thank you.
Regarding the bundles, does it work well with source mapping?
Again?
The source maps. If you have somehow bundled code in production, like I don't know how. What exactly does it mean?
So you're asking about source map, how well they work?
Yeah.
With...
What does it work with source map if you have it somehow extra bundled?
Well, I'm not an expert on source map. Let's say that first. To this point, I treat them as a little bit of magic. Not sure if anyone in the room has actually understood how source map works. No.
I mean, if you then want debug code in production.
Well, yeah, this is a pretty good question, because there was even a questionnaire recently from Chrome team. Like, what would we expect is happening when we run a debugger on a minified code, and some of the variable, it is named count here, but in minified code it would be, I don't know, X or B or something, and what would we expect if we reassign something to that variable, if it reassigns or if there is conflict. So there was a great question about this, and the thing that I can say towards that is that I don't really know. Like, I would expect that the bindings exist. Like, I can change count, and the F would change if it's really a count in the binding. But as soon as you run into complicated cases, the thing is that the best thing you could do with debugger is forget about minified code.
I mean, I think it kind of works if you have the source maps, and you can.
It works for errors. It works for bundle size analysis. But as soon as you start changing things, it stops working. That's also a thing when, for example, maybe many of you have already realized that editing some of the minifiled JavaScript doesn't work in Chrome if you do, things to that, and that's why you have to do the local overrides and all of the hassle around it. It's connected to that. Yeah. Okay. No questions?
What should we do with our variable types?
Delete them tomorrow.
What you could add a lot of slash something imports everybody.
Yeah, because like even if it's uglier, like from this perspective,
It's not all about beauty.
yeah, and nowadays the IDs will import it for you. They will collapse it for you. They will sort it for you. You don't even have to know the imports exist. So why are you still writing them in a barrel file? Oh, I was was expecting, you know, a skeleton or something. It's Halloween.
So what should we really do with NX? Because like it's the recommended pattern.
Yes,
Create
and-
libraries to create index.ts, exporting all of the stuff. And we had that discussion in another
Yes.
project. I remember, because like it's the recommended way, and
It is, and
all
if,
people who want to migrate to NX say create your library, create it in a verified, export everything from the library.
it is. And if you open up one of the issues that is at the end of the presentation, there is even a comment from one of the NX developers saying that like yes, you should really you should use barrel files if the code you are importing anyway has to be imported together, because then you are basically doing a good job. You are hinting to the bundler, this is something that needs to be together. You know, when there is a component and the component needs pipe and that component needs another component, then you re-export it together and all is fine. But as soon as your, for example, design system library has one huge barrel file re-exporting all the components, that's not what you should be. That's not what you are supposed to be doing.
Thank you, Chris.
Yeah, but you can also just have some entry points. So each library can have some entry points that has its own profile.
Yeah, that.
Minimizing that actual.
Yeah, but then what Chris is now saying is correct. But then what you are basically doing is optimizing or pre-optimizing that you will get rid of the execution context of all of the or overhead of all of the NX libraries, because there is of course an overhead in building it. So you can do it with entry points. Again, that is a suggested solution to that. If you really need to have a big library, entry points. But don't do, you know, utils lib that re-exports utils for all of your projects, and then wonder why my main JS consists of utils, RxJS, and app component. Because that's why. Because you put it all together, and Pepec is going through it and saying, oh, another util import, another util import. Not only seeing that import because it's not CSS, it's ESM, so it will go inside of the util import and see, oh, thousands of utils. Why not? Let's all put it together. They are probably needed because these developers are small, so smart, they put it together.
So, you know, imports you have to be as specific as possible, right?
Yeah,
But this is the easy part.
this is the easy part. Being
Be
specific.
specific on import level is the easy part.
Being specific on export is hard.
Yeah.
And you basically have two options. Either like don't be specific on export, just have everything separately and suffer the consequences of having everything separately, or do everything properly, sit down, architect your libraries, and go on the conferences and show off how good your infrastructure is. Okay, I guess that's it. Do we still have beer?
Enjoy more beer.